Today, we're going to explore a powerful concept in C programming known as structures. Let's see what is structure. Structures serve as a means to create a custom data type that combines various data types into one cohesive unit. Structure works as a template or blueprint that allow us to create our own data types. They are constructed by combining elements, similar to building blocks, each of which has its own data type. Structures consist of elements, and each element can be of a different data type. For example, we can have a structure that holds a name as a string, age as an integer, and salary as a floating point as its elements. It is important to define structures before you use them in your program. In C, there are three methods to define a structure. 1. Variable structures means defining a structure by directly declaring variables. 2. Tag structures means assigning a tag to a structure definition. 3. Type-defined structures means defining a structure and simultaneously creating a type using the typedef keyword. Structures provide a way to merge different data types into a single, composite data type. Variable structures allow us to define a struct variable directly. They don't require a separate struct tag. Instead, the structure definition itself declares the variable. Let's consider this example to understand struct variable better. In this example, we want to create a point structure to store coordinates without defining a tag separately. Here we are defining a structure that encapsulates two double-type variables, x and y. The name of the structure variable we create is point. This example combines the structure definition and variable declaration into one. It also creates a structure without explicitly defining a tag, allowing us to use the structure directly as a variable. Utilizing tag structures allows us to define new types in C programming and create variables based on these structured types. We can employ the tag to define variables, parameters, or return types in our program. In this example, we define a structure point T with x and y as its members. Subsequently, struct point T point1, point2, point3 declares three variables, point1, point2, and point3 of type point T, each capable of holding x and y values. A typedef structure enables the creation of variables without using the struct keyword, simplifying code and enhancing readability. The tag associated with the typedef structure can be employed for defining variables, parameters, and return types throughout the program. Consider the following example demonstrating a typedef structure. Now, let's see how this typedef structure can be utilized for variable definition. In this example, the variable emp has members such as SSN, emp type, and salary. In C programming, structures play a pivotal role in organizing related data. The dot operator is used to access and manipulate member variables within a structure. For instance, if we have a structure point T with members like x and y, we can access them using the dot operator that is shown in the setPoints function. Once accessed, these member variables can be utilized just like any other variables in C. They can be assigned values, undergo arithmetic or logical operations, or even be used as function arguments. When working with a pointer to a structure, using the dot operator to access members isn't feasible. The arrow operator enables direct access to structure members when working with pointers. Once accessed using the arrow operator, structure members can be manipulated like any other variables. In a structure, a member can be declared to be of another structure type. Consider this example, where structure person info T uses structure date T as the nested structure member. Nested structures help in organizing complex data hierarchies efficiently. They enhance code modularity and readability by grouping related data together. A structure in C programming can be initialized at the time it is declared. The sequence of values is used to initialize the successive variables in the structure. It is an error to have more initializers than members. If fewer initializers than members, the initializers provided are used to initialize the data members and remainder are initialized to 0 for primitive types. A member of a structure may be an array. In this example, structure time card T has an array member hours worked. The elements of this member array can be accessed as shown in this example. Similarly, we can also create an array of structures that contain arrays that is explained in this example. In this example, structure variable emp time is an array. Structures in C can be passed as parameters to functions, allowing us to work with complex data types more efficiently. We can pass a structure as an argument to a function, enabling the function to work with the structure's members. Inside the function, we access the structure's members using the dot operator. Passing structures as parameters avoids the need to pass multiple variables individually. In C, we can pass structure pointers as function parameters to manipulate structure members within the function. This method allows functions to directly access and modify the original structure. Consider the following function in this example that swaps the x and y coordinates of a point structure. The function takes a pointer to the point structure as a parameter and performs the swap operation. When a structure is passed as a parameter to a function with const, it implies that the structure remains unchanged within the function. Consider this example. We used const structure point as a parameter and modified the structure member values, which results the compilation error. It means we cannot modify the structure member value in a function where the function structure parameter is constant. In C programming, returning structures from functions can be approached in various ways. Scalar values like integers, floats, etc., are efficiently returned in CPU registers. This efficient handling in registers makes the return of single scalar values straightforward. Historically, C did not support direct structure assignments, or the direct return of structures from functions. However, the return of pointers, including pointers to structures, has always been supported in C. Returning a structure pointer to a local variable in C introduces risks due to the deallocation of stack space post-function execution. It is possible for a function to return a structure. This facility depends upon the structure assignment mechanisms, which copies one complete structure to another, and also avoids the unsafe condition associated with returning a pointer, but incurs the possibly extreme penalty of copying a very large structure. Here is an example that shows how a function can return structure values.